Hello friends. So continuing the journey in algebra further. So what all we have done till now? Yes, we have done till now all about linear equations. Then we move to all about quadratic equations along with some knowledge about polynomials. Okay. And then finally we saw inequations in the last video. All right. In today's session, I wish to cover something about functions. Okay. Now, if you want to understand functions better, you need to first understand relations, yes. And to understand relations better, obviously some basic knowledge of set theory must be there, which you know already. Okay, don't worry. Let's see. So let's understand what do we mean by relations. For example, I have written a set A which contains these 5 elements. See, writing a set, you know very well, there can be two ways: roster form, set builder form, right? I have written in this roster form. Yeah, you can also represent the set by Venn diagram. All those basic things about set theory we already know. All right, friends. Okay. I have taken one more set, set B, in which there are 4 elements A, B, C, D. Now, what do I mean by Cartesian product of A and B? See, we are just developing relations. So how to develop a relation? For that, we need to understand what is Cartesian product of A and B. Yeah, see, it is written as A into B, but don't read it as A into B. Read it as A cross B. Now, what do we mean? I mean by A cross B. It's a set only. It's a set. So it will contain some elements, some well-defined distinct elements. So which elements are there? Elements will be in the form of ordered pairs. Ordered pairs means, see, first let me read this set. Set of all the ordered pairs x comma y such that x, the first element in that pair, belongs to set A, because you have written A cross B. So first you will pick up the first element in every bracket from set A, and Y, the second element, will belong to the second set B. B was second in A cross B. So order is very important. So what do I mean by ordered pair? Let's see an example. Simple example through the graph. So if I choose two numbers, 1 and 2, the order in which I write 1 and 2 is important, isn't it? Because 1 comma 2 and 2 comma 1, both of them contain same numbers, but the order is different. Does it mean that both of them will represent the same point on the plane? Of course not, right? You can see here 1 comma 2 and 2 comma 1 are both different points. So order in which we write the values matters. So in 1 comma 2, x coordinate is 1 and y coordinate is 2, and in 2 comma 1, x coordinate is 2 and y coordinate is 1. All right. I hope you all are with me till here. So I'm developing Cartesian product of A and B. As of now, I just wrote the definition. Now let me develop and show you actually what it is. Also, before going ahead, what will be B cross A then? Yes, it will be again a set in which ordered pairs are present, but here the first element of every pair will come from, yes, the set B, and second element will come from set A. Okay, all right. So you should understand that A cross B is not necessarily same as B cross A. The order matters. All right, 1 comma 2 is not same as 2 comma 1, something like that. And what do you mean by cardinal number? I hope you remember in set theory we had done it. N of A, number of elements of any set is called as cardinal number. Okay. So here set A had 5 elements. So cardinal number of set A is 5, isn't it? Yes. Cool. So let's develop A cross B. It's a set. So it will contain ordered pairs. A cross B I have written. So first element will come from set A. Second element will come from set B. Set A में क्या था याद है? 1, 2, 3, 4, 5. So I'll pick up, I had picked up 1 from set A, and in set B I had A, B, C, D. So you can create a 1A, then pair 1 with B, then 1 with C, 1 with D, like that. Similarly, change the first element now. It can be 2A, 2B, 2C, 2D, and so on. 3A, 3B, 3C, 3D, 4A, 4B, 4C, 4D, 5A, 5B, 5C, 5D. Okay. So how many elements you could see here? Yes, there are 5 rows, and in every row there are 4 elements. Of course, 20, right? So cardinal number of A cross B is 20, which is same as there were 5 elements in set A and 4 elements in set B. So I can also say number of elements in A cross B is nothing but number of elements in A multiplied by number of elements in B. Of course, if you want to build number of elements in B cross A, it will also be number of elements in B into number of elements in A. So this will also be same as number of elements in A cross B. So number of elements will be same in A cross B and B cross A, but the set itself will not be same, right? So in B cross A, if you see the first element will be A comma 1. Now 1 comma A is not same as A comma 1, isn't it? That is why A cross B is not necessarily same as B cross A. While counting the elements, number will be same. Okay, comfortable till here? Okay. Now, so finally, what is relation then? Yes, relation is a subset of this Cartesian product of two sets. Means out of these 20 brackets which you can see, yeah, I have created the pool of all the possibilities. From that, I'll pick up some elements or some brackets according to some relation. I'll think of some relation. I want to relate the first element with the second element through some logic. So whichever brackets or whichever elements will satisfy that logic or that relation, I'll pick them up. So I'm picking them up from this set only. That is why I said relation is a subset of the Cartesian product of these two sets. And this is how we write the notation of subset, isn't it? Okay. All right. Now I have chosen a particular relation C, 1A, 2B, 3C, 4D with some logic in mind. It's like first element I have chosen the numbers 1, 2, 3, 4 and corresponding positions of alphabets in the alphabet set I have chosen as A, B, C, D. I can also represent this in a diagrammatic form as this, something like ovals. Set A had 1, 2, 3, 4 and then the relation R. Through this relation I'm relating the elements of set B. Yeah. So 1 with A, 2 with B, 3 with C, 4 with D. See, I've just connected them by arrows. Yeah, you can say A, C, D, B are like images of 1, 3, 2, and 4 respectively. So 1, 3, 2, and 4 will also be called as pre-images of A, C, D, B. Okay. Yeah. Okay. Next word, domain. What do we mean by domain? Set of all the first elements in those brackets of relation. Yeah. So pick up all the first elements. 1, 2, 3, 4 forms the set which is called as domain. Now range. So whatever the second elements are in every bracket, that is set of all the images is range. Set of all the pre-images is domain. Set of all the images is range. So first elements were 1, 2, 3, 4. They formed a set called as domain, and second elements are A, B, C, D. So they formed a set called as range. Okay. All right. And set B entirely is codomain. All right. Now there can be two possibilities based on the relation between the codomain, that is set B, and the range. It's not necessary that all the elements of codomain will be like images of domain. Sometimes you might see some particular elements in set B, that is codomain, may not have some pre-images, that is they are not connected. So based on that, see, ultimately we can derive this, conclude this, that range will always be a part of codomain. A part of means subset of, the hi-fi word. So range will always be a subset of codomain. And as we have studied in subset, there are two types of subsets, isn't it? Proper and improper. So if range is a proper subset of codomain, means codomain will have at least one extra element, which is not in range, isn't it? It's like codomain थोड़ा बड़ा होगा रेंज से और रेंज छोटा होगा. रेंज छोटा होगा कोडोमेन से तो रेंज ऐसा कोडोमेन के अंदर चला जाएगा, something like that. So you can remember like this. So it will also be called as into relation. Yeah. And when range and codomain are same, it is called as onto relation. कोडोमेन जितना है उतना ही रेंज भी है, तो it will fall onto that ना. So onto relation And one more hi-fi word for onto relation you should remember is surjective. Sometimes if you see the word surjective, you should understand it as ये अपना onto relation ही है, मतलब range and codomain are exactly same. Codomain का कोई भी element छोटा नहीं है, which is not connected to domain. Okay. Now see this one. This particular relation which I have drawn here, 1 with A, 2 with B, 3 with C, 4 with D. Here you see the connection. Which kind of connection is there? One element of A got connected to one element of B. So this is also called as one-to-one relation, and another word is injective. Also, you can observe here that every element of set B got connected to the element of set A. Means here codomain, that is set B, and the range both are same, isn't it? So codomain was ABCD. Range is also ABCD. Both are same. So improper subset, right? So here, apart from being one to one, this is also onto. Can I say this is also onto? Yes. Perfect. Yeah. So in such kind of cases, when a relation is satisfying both the conditions, that is one to one and onto, then we call it as bijective relation. That is injective plus surjective. Okay. Understood till here? So one to one, onto, into, surjective, injective, bijective. Get comfortable with these words. All right. Cool. Let's explore some more relations. Yeah. See this. What are the observations? Is it one to one? Of course. Every image inside B has only one pre-image. Means every element of codomain got connected to only one element of domain. So one to one. Yeah. Is it into or onto? Observe set B, that is codomain, and the range. Here range is what? Set of all the images. So A, B, and C only. Codomain is A, B, C, D. So here range is lesser than codomain. So yes, it's a proper subset. So it's into relation, isn't it? So it is one to one and into. All right. Observe this. Yeah. Is it one to one? No, right? Can you see here one connection? B, element B in codomain has two pre-images. One is connected to B and two is also connected to B. So in this case, I cannot call it as one to one. So more than one element of domain are having only one image in codomain. So this will be called as many to one. Yeah. And of course, codomain has one element extra than the range. So range is a proper subset of codomain. So it's a into relation. So I can club it both and call it as many to one and into relation. Okay. I hope you remember 1, 2, 3, 4 forms set of pre-images, ABC are images. So your range was a proper subset of codomain. Codomain has something element extra, one element extra. That is why it is into relation. अगर वो D भी cover हो गया होता तो it would have been onto. Okay, comfortable. All right. Okay, so after understanding relations, now finally we are in a position to understand functions. Yeah. Functions as a word, don't you feel it's like a familiar word? Nothing new, not a typical mathematical word. Anybody will understand if you say the word function, because it will be used, it is used in three different contexts, right? Yeah. First of all, that context is work, functions of your mobile phone, functions of your brain, something like that, the work performed by some machine. Correct? Then ऐसा बोला नहीं है क्या, अरे आज वहाँ पे बहुत बड़ा फंक्शन है, लेट्स गो देयर, टुडे आई हैव अ बिग फंक्शन इन माय फैमिली, some event. Yeah. And finally, the third context, which will be important here in mathematical context? Yes. First of all, let me give you a simple example which we have studied in school so many times. In geography, agriculture in India is a function of rain. I told you in English and I wrote it mathematically. What is the thought you get from this? Agriculture in India is a function of rain. Yes, one thought, that rain and agriculture have a relation. Which kind of relation? Agriculture depends on rain. Yeah. So here it was like dependence. In this context, also you can use the word function, dependence. So rain is of course an independent variable and agriculture is dependent on rain. Okay. So let's take it further and generalize like this. So we will be studying the functions under this context, that y is f of x, y is function of x is independent and y is dependent. Y follows x. कैसे भी याद रख सकते हो. Okay, cool. All right, let's go ahead. So these are some parameters which we are going to study. Yeah, let's see the intro. So you can treat the function like a machine. So function is like a machine. See this machine which is performing some operation, some work, some function. 2 into x plus 3. What do you see that x as? You should see that x as an input, isn't it? So input is x and output is y. So basically this 2x plus 3 is the value of y. Y is also called as f of x, function of x. Okay. So if you input 1, output is 5. Machine, you're understanding, right? Something like, suppose you have a fruit juicer. Input is fruit, output is juice. Okay. 2 into 1 plus 3. I hope you understood, it is 5. If you put 2, so 2 into 2, 4 plus 3 is 7. If you put 3, 2 into 3, 6 plus 3, 9. If you put 10, 23, correct? If you put a square, so in place of x only, you have to put that variable, put that input. So x is like a variable which will accept all the values of inputs. Okay. So 2a square plus 3, isn't it? All right. So as you saw, we can choose any value of input here. So we can again say that input is nothing but independent variable and output is dependent variable. Okay, so y is dependent on x means y is a function of x. And this is how we write. Okay, all right. One more notation which you should understand. You can write 5 as f of 1. That is value of f of x when x was 1. 7 f of 2, value of f of x when x was 2, and so on. So I hope you got comfortable with these notations now. Okay, cool. Sure. Let's go ahead. Same. Input 1, output will be f of 1. And what is f of 1 ka value? 2 into 1 square plus 3, that is 5, right? Input 2, output similarly will be 11. Input 10, output will be 203. 10 square 100 into 2 प्लस 3. सो मशीन को इंस्ट्रक्शन क्या है, जो भी अंदर है उसको स्क्वायर करने का, डबल करने का, एंड देन 3 ऐड करने का, एंड दैट विल बी द आउटपुट शोन. Kind of programming in the background. Yes. -2. Come on, guess it. Superb. 11. F of -2 is 11. ठीक है. A square. Yes. 2 times a raised to 4 plus 3. Isn't it? A square ka square. So a raised to 4 double, then add 3. All right. Did you observe something? Here there are two outputs which are same, 11 each. But inputs were different, 2 and -2. That's perfectly fine. Yeah. So here two outputs were same, even though they were two different inputs, but they gave you same output. In the context of relation, if you remember, it can be called as many to one. सो 2 का इमेज 11 है, -2 का इमेज भी 11 है, मतलब 11 के दो प्री इमेज है. करेक्ट. That's absolutely fine. So finally, let's summarize some condition for any relation to become a function. See, function is also a relation only, right? So all functions are relations only, but all relations need not be functions because there is some condition attached. Check this. So a function relates each element of a set, that is input, with exactly one element of another set, that is output. With exactly one element, huh? Output should always be unique. The moment for one particular x there are two values of y, it won't be a function only. Okay, check this. ये चलेगा? Of course, every time I could see a unique output, chalega. So in any function for any value of x, there's always one value of y. Yeah, check this. 1-to-1 kind of relation, right? Function hai ye, because output is always unique. Yes? Okay. But the moment you have something like this, for one input, two outputs, it won't be a function. Okay? So for every input, let me just rephrase the conditions. You can say there are two conditions. For every input, output should exist. Means you have to choose values of x in such a way that values of y should exist. And when y exists, it should be unique. Okay. Yeah, something like if I have y is equal to root of 1 minus x. ये भी तो एक function है. If I choose x as 2, y क्या होगा? Root of 1 minus 2. So root of minus 1 not possible. It's an imaginary number, remember? So in the context of function, when we are learning y is equal to f of x, our by default thought is set of y, set of x should always be real numbers. Okay. So here input cannot be 2. Means in such kind of cases, there will be some restrictions on input. That is when some questions you will see that find the domain. So set of all the inputs will be called as domain. Yeah. So set of all the acceptable values of x will be called as domain. So here also we have the same word. And set of all the outputs, so set of all the corresponding values of y for every value of x will be called as range. Okay. So set of all the inputs, that is set of all the acceptable values of x is called as domain. And set of all the outputs, that is set of all the values of y will be called as range. Okay. For example, your fruit juicer, you can input only fruits, right? Apart from fruit, you can't enter anything. You can't input like a stone. Machine बंद हो जाएगा, खराब हो जाएगा. All right. I hope you got the context. ठीक है. So output should always be unique, isn't it? Just now in the previous example, we had seen that two different inputs had same output, but the main condition was not disobeyed, right? Output was unique, na 11 ही आया था ना. So any value of y, there can be more than one value of x. So it can be many to one. It's fine. As long as output is unique, there is no problem. So out of all the relations, one to one and many to one can only become functions. One to many to many cannot be a function. All right, cool. This is perfectly fine, right? Many to one, because output is unique. मशीन को क्लैरिटी होना चाहिए कि क्या प्रोड्यूस करो आउटपुट. Something like in your mobile phone, you have full control over your mobile phone. Whatever you want, only that will happen, because at every step you are being given a choice. Nothing will happen without your wish, your permission. अगर आपकी इच्छा के बिना ही कुछ होने लगे तो आप मोबाइल यूज ही नहीं करोगे ना, कि आप कुछ और प्रेस कर रहे हो, कुछ और ही प्रेस हो रहा है और कुछ और ही हो रहा है. अनकंट्रोलेबल. Yes, so these things are kept in mind while programming for all those things. Okay. Let's see. Identify the function through these three examples. First one. So y is equal to minus 3x plus c. You can write it as, right, a linear function, straight line. For every input, there will be only one output, isn't it? Okay. So this will be a function, right? So for every input, you'll always see only one output. So here, y is a function of x. The second case, first write y in terms of x. Yeah, so y square is 25 minus x square. If you choose x as 3, 25 minus 9, y square is 16, so y is plus or minus 4. Oh, two values of y for one value of x. The basic condition only got violated. So it's not a function. Correct? Similarly, in the next one, y square is 25 minus x. Same thing. If you choose x as 9, so y square is 25 minus 9, that is 16. So y will be plus or minus 4. For one input, there are two outputs. Not possible. Not a function at all. I hope that condition is becoming clearer and clearer. All right. But here, if I see like this x in terms of y, so 25 minus y square. Now for input is y, output is x. So we have changed the entire context. I hope you're comfortable. That is how I've written x equal to f of y. So y is input, x is output. Y is independent, x is dependent. If you choose y as 3, so x will be 25 minus 9. So x is 16. For output is unique. Na? So now it's a function under the context of x is equal to f of y. Yeah, just understand this much. Don't think too much. Be comfortable. Okay. All right. You know, graphically also we can understand this. There's something called as vertical line test. See, if I draw the graph of this first one, that is a linear function. Remember, na? Straight line. Imagine vertical lines. Keep drawing vertical lines mentally and just check whether those vertical lines will cut this blue line at one point only or more than one point. Of course, if you keep imagining, yeah, vertical lines, every time those vertical lines will intersect this blue line at one point only. That is, for every value of x, there will be only one value of y. So it's a function. Check this. Now, first of all, those who don't know, this is the graph. This will be the graph of a circle. Y square plus x square equal to 25. This is nothing but this will represent a circle. This is algebra and this is geometry. So we are applying algebra in geometry, the third branch, coordinate geometry, which we are going to learn in further episodes. Stay tuned. All right. So graphically, we have drawn a circle, and those who understand the coordinates properly, they must have visualized. Now, if you draw a vertical line now, at every input, there will be two outputs because the vertical line is going to cut this graph of circle at 2 points. Yes. Anywhere you imagine a vertical line, you'll have two values of y. So it fails the vertical line test. So it's not a function. Okay. Understood? All right. Let's recap domain, codomain, and range. Yes, friends. Let's take this simple example, x plus 3. So whatever values of you choose, kiska x ka. So set of certain values that input x can take, certain values means acceptable values. So if x is 1, y is 4, x is 2, y is 5, and so on, x is 3, y is 6. Okay. So you can represent it diagrammatically. Yeah, so domain is 1, 2, 3. And range. See, codomain is by default whatever set you decide. 1, 2, 3, 4, 5, 6 here. So range was only the images. So 1 ka 4 se tha, 2 ka 5 se, 3 ka 6 se. So range is 4, 5, 6. Codomain is entire 1 to 6. Is it 1 to 1? Yes, it is 1 to 1. Injective. Is it onto or into? Remember, कोडोमेन बड़ा है, रेंज छोटा है. So into अंदर जाएगा. Yes, into. All right. Let us understand some standard functions which we should know by default, which we're expected to know. All right, friends. Okay. First one is very easy. Identity function. Identity function है क्या देखो. Y is equal to X. जो इनपुट है वही आउटपुट है. Kind of lazy function. Machine is not doing any extra work. जो इनपुट आ रहा है वही आउटपुट है. Yeah. You know that you can also write y as f of x, right? So f of 3 will be 3. F of minus 3 will be minus 3. No additional work. जो input है वही output है. Okay. Great. If you want to visualize this graphically, it's a very simple graph. Yeah. If x is 3, y is 3. If x is 5, y is 5. Yeah. X is minus 2, y is also minus 2. So keep taking some values and join all the points. You'll see that it's a straight line passing through origin, perfectly bisecting the first and the third quadrant. Okay. ये वाला angle भी 45 degree होगा. Later on, you will learn more in detail about this in our coordinate geometry topic. ठीक है. Next is constant function. Okay, friends. Constant function, as the name suggests, output is fixed. A fixed output, irrespective of any output. मतलब अगर वो लेजी था तो ये तो महा लेजी हो गया. देखता भी नहीं इनपुट कौन है. नो रिस्पेक्ट. जो फिक्स्ड आउटपुट है वही प्रोड्यूस करेगा बार बार. लेट्स से इट इज 3. मींस f of x is 3. So if x is 3, y is 3. If x is minus 3, y will be 3 only. ना आउटपुट कांस्टेंट है, फिक्स है. लेट देयर बी एनी इनपुट, हर इनपुट पे एक ही आउटपुट आएगा, दैट इज 3 ओनली. ओके. कैन यू इजीली विजुअलाइज दिस एज अ ग्राफ? यस. हर बार y3 ही आने वाला है. यू चूज एनी इनपुट. Correct? Yeah. So ultimately, if you join all the points, you will see that it's a straight line parallel to x-axis. So y is equal to constant will always be a straight line parallel to x-axis. Means ultimately a horizontal line. All right, let's go ahead. So next is absolute value function. I hope you must have heard this word before. Absolute value. Another word is modulus. Modulus. Correct? And short में बोलते हैं mod. All right. So y is equal to mod of x. So let's see. Let's first take some values to visualize this better. F of x is mod of x. So f of 3, mod of 3. And mod of 3, if you know, is 3. कुछ तो basic बता देता हूँ. You know very well that output can never be negative. Yeah. Input can be anything, but output will never be negative. So it can be either 0 or positive. You can't say it is just positive. Okay. So f of minus 3, 3. 5.7 पे भी 5.7 आएगा. Minus 5.7 पे भी output mod of minus 5.7. So ultimately 5.7 positive. चलो let's visualize a graph. प्लॉट कर रहे हैं वैल्यूज और क्या. ठीक है. -2 पे भी 2 आएगा. Means the graph, if you visualize, can never go below x-axis because y is always either 0 or positive, never negative. So graph will be above y-axis only, friends. So ultimately, if you join all the points, you will see something like this V. Okay, mod of x का graph is like a V. V का जो tip है, we also call it as vertex. It will be origin. All right. Cool. और एक लॉजिक याद रखना. See, you might have accepted it. Mod कभी negative नहीं होगा. But why? Technically, modulus is like a Greek word. English में उसका मतलब है distance. So mod of x is distance of x from origin. Origin से distance measure कर रहे हैं हम. So reference point is origin. All right. Yes. Cool. Next is integer value function. As the name suggests, integer value function. We can look at it in two parts: greatest integer function and smallest integer function. All right. Notation is in that rectangular bracket. X is written inside a rectangular bracket. Okay. So f of x is box of x बोलते हैं. But don't worry. I have seen in the questions, they always define it, box of x. What do they mean by it? Yeah. So the output is greatest integer less than or equal to x. Hold on, don't worry. I know initially you might feel something disturbing. अरे क्या लिखा है? Greatest लिखा है, less लिखा है. Wait. Visualize the number line first. Okay. Now, if x is 2.7, if input is 2.7, let's analyze what should be the output. One thing is very clear, na? Output will always be integer. What do I mean by integer? Those three magical words, isn't it? Numbers without decimal. Yeah, numbers without decimal. तो आउटपुट का जो भी नंबर आएगा उसमें डेसिमल नहीं होगा. करेक्ट. ऑल राइट. So forget about the word greatest. First analyze this much. Integers less than or equal to x. अभी equal to x यहाँ पे तो हो सकता नहीं because 2.7 itself is not an integer. So output has to be an integer but less than 2.7 now. तो machine क्या करेगी? Left में देखेगी. Less than ना. Now to the left of 2.7 there are so many integers. 2, 1, 0, -1, -2, -3, -4, -5 up to negative infinity. बहुत सारे हैं. So what does this mean? For this particular input, there are so many outputs. Will it be a function then? No, right? Because output itne sare hain. And we know that machine should produce a unique output. Now comes the role of this word greatest. Out of all those integers which are on the left side of 2.7, which one is the greatest? Of course, of course 2, right? Which was just to the left of 2.7. सो लेफ्ट में फर्स्ट इंटीजर आंसर होगा अगर इनपुट खुद इंटीजर नहीं है तो. सो बॉक्स ऑफ 2.7 इज गिविंग यू द आउटपुट एज 2 एन इंटीजर. सो कम ऑन गेस व्हाट विल बी द आउटपुट इफ इट इज 4.5. करेक्ट. लेफ्ट का फर्स्ट इंटीजर. सो 4. यस. 0.99. कम ऑन. ऑफ कोर्स 0. गुड विजुअलाइजेशन था. थैंक यू. अब तक यहाँ से देख के ये फील आ रहा होगा कि फंक्शन खाली डेसिमल हटा देता है ना. 2.7 में 0.7 हटा दिया, 2 आ गया. 4.5 में इट इज लाइक ओनली 4. 0.99 में इट इज ओनली 0. सो इज दिस द थॉट विच यू आर गेटिंग? लेट्स सी सम मोर एग्जांपल. ऐसा नहीं है. सो -1.2. -1.2. if the function simply removes the decimal, so output should be -1. But -1 is bigger than -1.2. Yes. First integer to the left. Yes. So output is -2. So it doesn't mean that function only removes the decimal point. Please don't be under that impression. If the input is not an integer, output will be an integer. First integer to the left of that decimal number. To the left of, because output should always be less than the given input if it is not integer. And if it is integer, equal to that input. Okay. So come on, quickly. -3.5. If the input is -3.5, output will be? Yes, -4. Awesome. Great. Box of 3 now. Yes, input itself is integer, so there is no extra work done by machine. Output will be same as 3. Because equal to option hai na, so output will be 3. So if input is -3, output will be -3. Super. All right. So f of 3 will be box of 3, that is 3. -3. Yes, it will be -3. F of 5.7. Visualize, come on quickly. Left of 5.7. Yes, it is 5. -5.7. Left of -5.7. First integer is -6. Okay. Great. Okay. Now, graph. You know, if x is 0, 0.1, 0.111, 0.12, 0.2, up to 0.99999, output will always be integer, that is 0, isn't it? And if x is anything from 1 onwards up to 1.99999, output will always be 1. So for all these red line, that is all these values of x, output will be that blue line, 1. And if x goes from 2 onwards, that is x is 2, y is 2, x is 2.1, still y is 2, right? So add 2, output will jump to 2. The next step you see is it's going to be like a ladder. So 2 पे 2 है, 2 से लेके 2.99 तक output will always be 2, right? The integer 2. So it moves in this manner. So similarly, for the next set of numbers, output will be 3. At 4, it will jump to 4. It will remain 4 till x is 4.99999 and so on. Yeah. And if x is suppose negative minus 1 or negative minus 0.1, minus 0.1, the left ka first, so output will be minus 1. It will remain minus 1 till x is minus 1. Okay. So on the left side also, it will proceed like this. So ultimately, you will see this graph getting developed. Yeah. So these red dot means at x equal to 2, output is this and not this. So here, generally in books, you will see a hollow circle just to show you that at x equal to 2, y is not 1, y is 2. So hollow means it is not a part of that. It's not included, and thick means it is included. Tickly apna, tickly. Okay, cool. Next is smallest integer value function. This can be the notation curly bracket or simply the small bracket. Here, the output is integer for sure, more than or equal to x, but smallest integer more than or equal to x. We'll analyze in the same manner. I hope now you should be more comfortable. If x is 2.2, output should be more than 2.2 because it is not integer. So any integer more than 2.2. So उसके right में सारे integers. So it will be 3, 4, 5, 6 up to infinity. So many outputs. But output should be unique for it to be a function. That is why this word smallest will play a big role here. So out of all the integers which are above 2.2, the smallest one is 3 only. Na? It means right ka first. Yes. Now machine will select first integer to the right of that number. Okay. 3.5. Yes. Output will be 4. 0.1. Correct. 1. Minus 1.8. First integer to the right. So minus 1. Isn't it? Minus 3.5. First integer to the right side. Minus 3. Awesome. Superb. And when the number itself is integer, same answer. Correct? Minus 4, it will be minus 4 only. Okay. Let's practice it once more. F of 3 will be 3, minus 3 will be minus 3 only because these are integers. 5.7. Integer to the right side of 5.7, that is 6, isn't it? Minus 5.7. Right side, minus 5. Correct. And the graph will also be like a similar one. Yes. So when x is 1, output is 1. When x is 1.1, output will be 2. But when x is 0, output is 0. X is 0.1, output is 1. Right ka first, na? So earlier for greatest integer value function, left का first था. मतलब वहां पे ये x अगर 0 से लेके 0 point something something से लेके पूरा 0.99 तक होगा, so output will be 0 only. But now output is 1, so it will shift by 1 place up, एक यूनिट ज्यादा. ओके, तो पूरा ग्राफ अभी देखोगे तो एक स्टेप ऊपर शिफ्ट हो गया है बस, है ना. पहले वो ब्लू लाइन यहाँ पे थी, here, now it shifted up by 1 place. सेम वे अभी ये वाला यहाँ शिफ्ट हो जाएगा. इट इज राइट का फर्स्ट इंटीजर ना, तो उससे एक ज्यादा होगा. ऑल राइट, so it will proceed in the same manner. I hope you remember thick dot and hollow circle, thick circle का meaning. All right, ladder shape. Sometimes you'll also see the word for it as step function. So step function is also nothing but integer value function only, friends, because of the nature of the graph. All right, cool. Okay, next is our quadratic. We know very well, right? It will be a parabola, remember. Now 3 cases based on that delta. Remember whether the parabola will touch, not touch, or cut what? X-axis. So here it is cutting at 2 points, means there were 2 real numbers and different numbers. So delta more than 0, delta equal to 0, only one root, delta less than 0, no real root. And all this is under the assumption that A is positive, right? Correct. A means coefficient of x square. Now, if coefficient of x square is negative, downward parabola. Again, you can show those three cases, isn't it? So overall, six cases. All these six cases we had discussed in quadratic video very well. Okay, a good revision. Chalo, next is composite function. As the word suggests, composite, mixture of two or more. So minimum there should be two functions. So let's club those functions, understand how it goes. So input is x, it went to the machine of f. Output is x plus 3, or you can also call it as f of x. Yeah. Now this output will become input for some other machine. Yes. So look at this. In place of x for g, there will be the input called as f of x. So output will be g of f of x. बराबर ना, ये पूरा input बन रहा है, तो this will go here. So this input is now f of x. So output is g of f of x. This is your composite function, right? A function of a function. You know, we also write g of f of x as gof, gof. Gof of x लिखते हैं तो sometimes only gof. तो कैसे समझना चाहिए? x आएगा पहले f के मशीन में जाएगा, उसका आउटपुट g के मशीन में जाएगा. gx is another function only, just the notation g. Yeah. So let's take an example. F of x is x plus 3, g of x is x square. So g of f of x मुझे derive करना है. So f of x will be what? Yes, x plus 3, isn't it? So now output will be g of x plus 3. And what does the role of g of x machine is? Input, square it. So now input is x plus 3, it will square that x plus 3. So g of f of x will be ultimately square of x plus 3. So gof का आंसर आ गया x plus 3 the whole square. A single form. So यहाँ पे आपको दो फंक्शन दिखना चाहिए कि इनपुट आया था +3 हुआ, that is one function, then उसका square हो गया second function. So it's ultimately a composite function. Got it? All right. Let's do one more way. और एक थॉट हो सकता है ना, इनपुट सपोज x आया, वो g के मशीन में गया पहले. So first input जो g का मशीन में गया, and that output, that is g of x, is an input for f of x. So output will be f of g of x, right? So g of x is the input for f of x now. So in place of x, there will be g of x. So f of g of x, fog of x. All right. Okay, I know what are you thinking. Okay. Let's derive the relation for that also, formula for that also. So input for f is now x square, and whatever the input is, उसमें +3 होता है. This is the job of this machine f. So in place of x now there is x square. Yes, so f of x square, so it will be x square plus 3. You saw both are not equal. Yeah. In this case, sometimes they might be equal, depends upon the function. Okay. All right. Now the last one, even function and odd functions. What is even function? Look at this definition. How should you read this? How should you go about it? Here, input was earlier x, and now new input is minus x. What does that mean? Input has changed sign, but see the value f of x and f of minus x, both are equal. Means outputs are same. Yeah. So if both these are equal, then we say that it is an even function. So input changes sign, but output doesn't change sign. Output remains same. It's an even function. For example, f of x equal to x square. F of 2 will be 4. F of minus 2 is also 4, isn't it? So f of 2 is same as f of minus 2. So input changed sign, but output did not. Yes. One more example. Don't be just under the impression that the power should be only even, then only it is even function. Not that way. There's one more example. F of x is mod of x. Yeah. F of 5, you know very well now, is mod of 5, that is 5. F of minus 5, mod of minus 5 is ultimately 5 only. So here also we saw that f of 5 is same as f of minus 5. Outputs are equal even if input changed sign. Yes. Let's apply it graphically. So input x था तो y जो भी था, but input, the here input was 1, output was 2. Input became -1, output is still 2. Something like that. Input 2, output 5. Suppose for some particular function, input became -2, output is still 5. अगर ऐसे ही होता रहा, so see, ultimately what will you see? Did you see this? Input is 4, output is -2. Input became -4, output will still be -2. Output should not change sign, right? Input 5, output -3. Input became -5, output is still -3. You can just join these points and you see the nature of this graph. If you see very carefully, it is symmetric about y-axis. So y-axis is acting as a mirror. Okay, even functions are symmetric about y-axis. So y-axis will act as a mirror. So you can flip both the parts about about y-axis. Sorry. So their graph will always be in adjacent quadrant, first, second, or third, fourth, like that. For this y-axis to be the line of symmetry, isn't it? Okay, remember this. Next is odd function. What should be the difference? Yes, now output will change sign. Input was x, output was f of x, input became -x. Now output is f of -x, but uska value is negative of f of x. Correct. So f of x का आंसर जो भी है उसको नेगेटिव करके अगर f of x से मैच होता है, then they are odd functions. Input changes sign, output also changes sign. Check this example. X is 2, y is 2 cube, that is 8. X is -2, y is -2 cube, that is -8. So f of 2 is 8, f of -2 is -8. So f of -2 का negative किया, then only it will become 8, right? So f of 2 is same as negative of f of -2. Cool. One more example. F of x is -x. F of 5 will be minus of 5. So -5. F of -5 will be minus of -5. So ultimately 5. Same relation. Okay. Graphically. Yeah. So x is 1, y is 2. Now x became -1. So y won't be 2. Y will also change -2. दिख रहा है? Both these points are like, you can take origin as the mirror. उधर से reflect हो रहा है, right? Or you can see like this point got reflected about y first, and फिर y से x भी along x also it got reflected. Means 2 times reflection. कि पहले इसका reflection suppose इधर आया, इधर से इधर गया. ठीक है? So it is like you will see now slowly symmetric about both the axes. Both the axes. So 2 पे 5 था, -2 पे -5 हुआ. तो पहले क्या था, 2 पे 5 था, -2 पे भी 5 था, बट वो 5 अब नीचे आ गया, -5. Symmetric about both the axes, or you can say in short symmetric about origin. Yes. 4 पे -2 -4 पे will become 2. Correct now. 5 पे -3 है, तो -5 पे 3 हो जाएगा. And then if you see, this graph will be symmetric about both the axes. Yeah, or symmetric about origin simply. So did you visualize? You can also see इधर का इधर reflect हो गया और ये फिर इधर आया. Yeah, or vice versa. Understood? All right. So relations and then functions. This much you should keep in mind. All right, friend. There is something more about it, which I'll be uploading in the next video. Yeah. So please keep watching this again and again till the time you don't understand. Thank you so much. Stay safe. Take care.